Given the location of the presentation today, the title I've gone for is Mind the Gap, but really we're looking at acoustic pipeline inspection. So we're going to start off with a bit of an overview of pipeline inspection and the current toolkit available to operators, ROV and ROTV. So another acronym, ROTV, and I'll explain that as we go. Then look at some of the new solutions that within Fugro we're bringing to the market, some new capabilities for shallow water pipeline inspection with ROTVs, and then deep water solutions using AUVs for pipeline inspection down to 3,000 metres. I'm just going to finish off with a bit of discussion about how we process and report this data and how we deliver the data to our end clients. Within Fugro, over the last few years, the deployment of the best technical solutions for pipeline inspection has really cemented our position as one of the providers of pipeline inspection services in Northwest Europe. And I think it's worth really just defining what we think of as the best technical solution. It involves having good quality vessels and subsea platforms, ROVs, ROTVs, having some of the best survey sensors and hardware mounted on those platforms, having software that's capable of acquiring, QCing and processing that data, tools for delivery of the data to our end clients, and all of that really gets brought together by having an experienced team of operators, our inspection personnel. Pipeline inspection in Europe anyway tends to be quite a seasonal business, so every spring we undertake training of our guys to get them back up to speed with the latest technology, the latest improvements to our flow. So we have this sort of ongoing training and retraining process, because it's really at the end of the day the people that are key to the success of any pipeline inspection. All this is overseen by dedicated project management who the project managers really pull this all together. In terms of pipeline inspection, we have two distinct but complementary offerings. We've got our ROTV based sonar inspection, or what we call acoustic pipeline inspection, and we've got our ROV based visual inspection. So this is our current toolkit. So the ROTV, I'll just, if you're not familiar with it, ROTV is a remotely operated towed vehicle. So it's similar in size to a box kite. You'll see a few of them on the show floor. But it's a tow fish, but it's a steerable tow fish. So it's got flaps and rudders on it, so the vehicle can be moved laterally and vertically. The primary payload on the system is a side scan sonar, and this enables us to acoustically image the pipeline. And from that acoustic image data, we can determine if the pipeline is in span. We can determine the burial status. If we can't see it, it's buried. We can determine if there's any displacement to the product, or if there's any debris or hard contacts near the product. And it's a rapid assessment tool, so we can pretty much cover about 140 kilometres a day, so it'll be towed at about 4 to 5 knots. So it's a high production tool. Then we've got our ROV, and this is really the in-depth engineering tool. It's got a payload on board that enables us to make quantitative measurements, so we can measure the height of any span on the pipeline, the length of any span. Using multi-beam echo sounder, we have pipe tracker tools that detect the pipeline when it's buried, so we can determine what the cover, what the depth of burial is on the pipeline. And then we've got typically 3 cameras of video, so we're videoing the pipeline from above and with boom cameras on the side, so we can pretty much image all of the pipeline. In terms of ROTV, within Fugro we've been undertaking ROTV-based pipeline inspection for over 20 years, and at a rough count we've undertaken over 100,000 kilometres of acoustic pipeline inspection. In terms of having to process and deliver this data, we've developed some enhanced reporting tools for turning this data around fastly and efficiently offshore. But the key product, the key sensor, is the high-frequency side-scan sonar. And for those of you not that familiar with side-scan sonar data, just going to explain the middle slide here. This black line you can see here, this is the acoustic return from the pipeline. And this banding here, we're seeing this is a shadow, and this is where the pipeline is in span. And so using our interpretation software, our geophysicists interpret the length of that span and the height of that span. This image here, this is a subsea manifold with a couple of pipelines coming into it. We've got some mattresses here that you can see quite clearly over the, well, clearly once your eye's tuned into interpreting side-scan sonar data. So it's It provides a sonar image of the pipeline, which is a valuable tool for first pass pipeline inspection. The ROV, on the other hand, is really the complete tool for inspection, repair and maintenance activities. So the diverse sensor payload and the intervention capabilities really make it the ultimate tool for IRM. It's also got the benefit of the ROV pilot that is steering the vehicle, can interact with the inspection engineer. And so if they see a specific area of interest, the vehicle can slow down, they can undertake some in-depth visualization or in-depth imaging of that, and then move on. So that ability, alongside the flexibility to undertake intervention activities